Hello, this is the final project for the statistics on the set of data number 1. That data represents the unemployment rates for the recent college graduates broken down by categories of their respective majors. After studying our dataset, we recognized that we would need to perform a one-way ANOVA test as it was clear our data was derived from separate populations that were categorized only one way. Furthermore, our data samples were completely independent of each other with no indication of matched pairs. Also, the samples were simple random samples of quantitative data regarding normalcy and variance. There were no outstanding outliers that caught our attention, which fit those distribution requirements. Without having three or more populations, there were no variances to compare. The main concern for ours was making sure that our sample sizes were nearly equal, as the ANOVA test would be moderately reliable either way. This leading us to our primary question: do unemployment figures differ by college or undergraduate major category? And if so, how? Before we dove into our one-way ANOVA test, the first explored our data deeper in order to make sure that we were on the correct track. We plugged in our data into StatCrunch to first examine its normacy. Our initial decision was to graph the data via the box plot with markers showing possible outliers. Upon observation, we noted three outliers, one at 0.149, second one at 0.152, and the last at 0.177. However, this did not deter our decision to continue with one-way ANOVA test as the distribution requirements are loose as we stated previously. Our only concern was with the variances, as we did not have three or more populations to verify that the samples have the same standard deviation. Although we kept this in mind, whilst performing the remainder of our test, we were not too worried as the variance can be up to 9 times the smallest variance, as we stated in the project summary. Our first step was counting the majors. We had multiple sections for each major. In ascending order, the complementing majors were agriculture and natural resources, arts, business, computers and mathematics, education, engineering, health, humanities and liberal arts, psychology, and science being the 10th mean. After exploring our dataset more intimately, we were prepared and confident to perform the rest of our analysis. Since we are conducting a one-way ANOVA test, our null hypothesis was naturally as follows. All 10 means are equal to one another. Our alternative hypothesis being at least one mean is different than the rest, it is also important to note that our selected significance level was 0.05. Our second step was finding the means of each major using StatCrunch. The results are as follows. Agriculture and natural resources 0.0563, arts 0.0705, business 0.0711, computers and mathematics 0.0798, education 0.0517, engineering 0.0633, health 0.0659, humanities and liberal arts 0.0865, psychology and social work 0.0721, and finally science 0.0549. As you can see in our attached StatCrunch output on the right side, our respective test statistic was reported to be 3.084, with the p-value equivalent to 0.002. From these outputs, we were able to draw our initial conclusion, which was to reject the null hypothesis. Because our p-value of 0.002 was smaller than our significance level at 0.05, we needed to reject the null hypothesis. We found significant evidence to support the claim that at least one of the means from our data set describing unemployment rates for recent college graduates broken down by categories of their respective majors was different than the others. Because we concluded that we were to reject our null hypothesis, we next needed to perform a tricky test to precisely determine which means or mean were different than the rest of our sample data. To do this, we use StatCrunch once again. In order to interpret the Tukey test, we needed to examine each individual lower and upper bounds in regards to which undergraduate major was being subtracted from the selected undergraduate major. So we'll be subtracting each subsequent undergraduate major mean from first mean, which is agriculture and natural resources. Our main concern while looking at the results from the Tukey test is to make sure that the lower bound is a negative number and that the upper bound is a positive number. If we have met this criterion, we can conclude that the interval contains 0, which means there is no difference in mean values. Upon inspection, we noticed no discrepancies from the mean values subtracted from first mean. So we continue to the next section of the test. We repeated the same process until we were able to locate an interval with a discrepancy when subtracting mean 5, which is education, from mean 8, which is humanities and liberal arts, the interval being 0.006 to 0.064. This result led us to the conclusion that unemployment rates for the college students with an undergraduate in humanities and liberal arts is higher than the unemployment rates for those with a degree in education. However, we see a similar and final discrepancy when subtracting mean 10, which is science, from mean 8, which is again humanities and liberal arts. This interval is strictly negative with a lower bound at negative 0.058 to upper bound at negative 0.006. Our conclusion in this case being that the unemployment rates for college students with an undergraduate degree in science are statistically lower than students with an undergraduate degree in humanities and liberal arts. And this concludes our testing. Thank you.
For our data set, we have the number of art museum visits and how they correlated with and if they were influenced by other variables that we will get to next slide. Our next process was determining which values to use by the p-value and the t-scores. We used the multiple regression test to remove a few of the variables to determine which we will use. After we completed that, we moved to the simple linear regression equation test to find the exact regression line. After that test, we used a scatter plot to find any outliers in determining the shape of our data. When the scatter plot showed outliers, we ran it again and found the same results. After the scatter plot, we used a residual plot to check the scatter plot points, and we found out that the best predictive value of the dependent variable is the mean of the dependent variable values rather than the value of the independent variable. The variables given to us were living status, household income, georegion, age of surveyor, children under 18, art museum, books owned, and art owned. With the multiple linear regression equation, we selected the significantly low p-values, which was the number of books owned which had less than 0.001 p-value. The other variables had higher p-value and a lower t-score than needed. After the multiple regression test, we switched to the simple linear regression equation to find the exact regression line equation. With this, we found the only variable that had a low p-score, high t-score, and high adjusted r-squared was the number of books owned. It showed the correlation of the higher number of books owned, the more likely they are to visit the art museum. For step 3, we chose to create a scatter plot using the independent and dependent values of our data. We decided to use a scatter plot to test the shape of our data and find if we have any outliers. We found our data to not be a straight line and contains outliers. We chose to run a second test of the scatter plot, but this time removed the outliers to see if there was a change in our plot, and there wasn't. After running the scatter plot test, we ran a residual plot test. With the residual plot, we found that our equation did not represent a good linear model. The shape of the residual plot was a U-shape, and it started as a clump together, and as the U-shape continued on, it thinned out. The different thickness of the data and general shape showed that the data doesn't have the same standard deviations and confirmed our suspicions on if our data was not a good linear model. After running the multiple linear regression test, the simple linear regression equation, the scatterplot graph test, and the residual plot test in StatCrunch, we determined with our graphs and calculations that the best predictive value of the dependent variable is the mean of the dependent variable values rather than the value of the independent variables.